Hi everyone. Hi everyone. This is Hamid. I'm leading AI platform partner engineering at Meta, and I'm here today to talk about Llama Stack with you. So, quick check if we have the quorum. Give me a second. Awesome. Perfect. So I think most of us are familiar with the Llama models. This is open source LLM that we release it from Meta, and it has great traction in the community. So we have had very positive feedback about it. And we historically always open source the model weights itself. And it was just last year that we started to get this feedback from the community and our partners that it might be helpful to add actually a framework around it. So that's where we started to release Llama Stack. And this is basically some of the feedback that we have heard from the community on what is happening and how we actually need to approach this. So I think all of us are aware as developers in the AI space that uh, building a Gen AI application is very tricky. There are so many moving parts into this, and all the tooling is very much scattered around the internet. So it's much harder to get it started and make sure that we have a good start and we are comfortable building cool Gen AI applications and we have all the tooling in one place. So it's usually a barrier for many of us as developers. So this is where we started to think that we need to have one framework that bring all these scattered tooling under one place, under one umbrella, and make the developer journey easier. Let them have one starting point and provide everything there to basically building the applications that they want. So this was basically the thought process about Llama Stack. So we published RFC basically on our GitHub repository, and we got some good feedback. Everyone reached out to us to talk about what is our plan and how we want to build it, how they can partner with us. And of course, IBM is one of the greatest partners for us. We work very closely with them. And Llama Stack is one of the initiatives that we are collaborating very closely. But what is Llama Stack exactly? So, Llama Stack is a set of standard APIs work with to work with Llama models. And what does it mean? Basically, I believe you have seen other standard APIs like OpenAI and others in this space before, but Llama Stack take it a step further. How do we approach this? Do you have a Llama stack as API and a CLI? That on the other side of the uh, this box, we have all us as developers, and on the back end, we have basically a tool chain and a set of APIs to work with Llama models. So if you look at here, we have basically defined a set of APIs. One set of APIs is about Llama agentic APIs. This is where we are providing APIs uh, to basically cover all the building blocks that we need to build an agentic system. Anything from memory, a prompt store, shields, assistant, orchestrator, to uh, the backends, where now we are introducing the model toolchain APIs, where whatever that we need in an entire model life cycle, we are going to provide it here. So everything from evals to fine tuning to basically continue pre-training, synthetic data generation, anything that we need when we get a Llama model, which is an open source weight, and we need to do some modifications or basically how to interact with that. So part of that is definitely inference, and the other part is like how we want to customize this model. So we need fine tuning, we need synthetic data gen, we need evals. So these are all the APIs that we are providing in Llama Stack. How does it look like? So we have a Llama CLI as basically the orchestration level here. And we have the APIs, the Llama Stack APIs. And so I talked about different components that we are going to need. We have the inference, post training components, evaluation components. And so going back to the original thought process here that we want to bring everything under one umbrella, for each of these components, we are defining a notion of adapters where all the familiar toolings that you have been working with to build your applications are going to be a backend or an adapter for Llama Stack. So you can see here, for example, for inference, now we have VLLM, Grok, AWS, Fireworks, and many other familiar names that you have been working to run your inferences for Llama models. They have an adapter for Llama Stack. So it's a seamless integration between Llama Stack and those providers. Similarly, for post training, now we have started with Torch Tune, which is a fine tuning library from PyTorch, as the first resident here to provide the fine tuning services. And we are expanding it to all other providers that they are very familiar in the space. So, including Hugging Face trainers and AWS infrastructure over there. Similarly, for evaluation, we have defined evaluation APIs that helps you to basically run evaluations on your models and agentic flows. So each of us, we are working with a set of providers. And like, if you look at our internal stack for each of us, we prefer a set of providers and a set of tool chain to work with. For example, let's say that for inference, we are using VLLM. For fine tuning, we are using Hugging Face. So we are providing this notion of distribution in Llama Stack, that we are packaging all of this together to make it easier for developers to use. And this distribution uh, could come as a container or could come as a Conda environment or virtual environment. So to make it easier for everyone to adapt in different levels, and if we need to scale, so container distributions could be very helpful to scale our services. So I want to make it a little bit more interactive, and I want everyone, if you have any questions, please ask questions. I believe like discussions about the core concepts, where we are going, roadmaps are way more important comparing to what I'm going to show you in a notebook. So please stop me wherever it's needed, and I love to have a discussion about any point that is a question for you. So just to show you, this is Llama Stack Base. This is the repository that we have built. And as you can see, this is under very active development. And good news is today we are just releasing v0.1, which means that our APIs are stable and backward compatible. The CI is up and running and everything is shaping very well. So that gives the ease of mind to all of our partners, including IBM, NVIDIA, and everyone else, to kind of seamlessly integrate their services into Llama Stack. This is where you can find basically everything that we have. And if you go to our docs, we have a good amount of basically material for you to get started easily. We have the Zero to Hero module here. which teach you everything from very modular. So everything from how to run an inference, how to use inference on local or cloud, how to do prompt engineering, chatting with your images, tool calling, and etc. So this is one great resource for you to get started. The other one is like we have notebooks here that I'm gonna actually go through this one today, and this one kind of showcase how you can use Llama Stack for different functionalities in a collab notebook, and as an inline library, which is very easy to play with. Also, we have this documentation. So if you go to Llama Stack, and if you can actually reach to our documentations here as well, which we have discussed all the core concepts what I have discussed it with you right now in much more details, how we are thinking about distributions, different type of distributions that we have, like remote hosted distributions like Fireworks and Together AI, which they are basically API providers and we are calling to their endpoints to run the inference and other functionalities, or local hosted distributions like Hugging Face TGI, VLLM, or Olama if you are running it on device. So different types of distributions that should cater different needs. Also, we have the on-device distro, which means that we have the SDK for Android and iOS. So please check out this documentation, and we have a Discord channel as well. That please, you are very much actually welcome to join over there and help us to build together. This is so if you go to the chats, basically you can get into our Discord channel, and that's a way to interact with us and raise questions, concerns, or feature requests, or anything that is interesting for you. So with that, I'm gonna switch to the basically a notebook that I talked about it a little bit. So as I mentioned again, like you can find it here under docs, notebooks. This is the this is the notebook I'm talking about. And here I want to go over some of the functionalities that we are basically providing today. So again, this is basically an outline of how we are approaching it in Llama Stack. We have the service providers, which those service providers could be anything from your vector DBs, inference, fine tuning services, and anything that you need in a model lifecycle to kind of get it to work effectively. Then we have this telemetry here to kind of track everything that is going on and kind of use it to uh, better manage our models, which is super important for production use cases. That's basically the focus here. We want to build something which is very helpful in production and is solid. That's why we are thinking of everything which is needed in production. And you can here see memory banks, models, shields, and data sets. So to double click on shields, basically shields are uh, the safety measurements that we are putting in place. So you might be familiar with Llama Guard as well, Llama Guard, Prompt Guard. That's the safety portion of the Llama model open sourcing, where we are putting out Llama Guard as a safety model that can help you to basically make sure that you have a safe deployment and you have a safe API, which is super important for all of us, especially in many of the domains like healthcare, finance. Super important to provide the safety. And on the top of that, so you can see different APIs that we are talking about: agents, post-training, synthetic, and everything that I just discussed about. So here, to get us started, we are going to use basically Together AI APIs here to make it easier not to go for a local deployment. So just to make it easy. So to use that, you need to set up a key over there, which I guess all of us know about it. So I have done it before, and so your keys can go here. So you can actually keep your keys here once you started this. And so here, I'm gonna install two things basically. One is Bubble Wrap, which is a very lightweight container framework to run some of the code that we want in the agentic flow. And then at the same time, I'm gonna install Llama stack. So this whole long thing is gonna be only Llama stack, and I'm putting this because just we are releasing v 0.1 right now. But this whole long string should be replaced by Llama stack. That's it, pip install Llama stack. So I have gone ahead and installed it already. And here, this is actually important. So how you want to build a distribution. So we talked about distribution as a packaging mechanism here to package whatever that you need to build a Llama application. So we are going to use our CLI here, which is Llama stack build, and then we are passing a template to that. So we have together as they have the integration as a template. And here with this image type, basically you can configure if you're going to build an environment or you want to build a Docker. So you can actually switch this one to be an image, which is going to build a container for you. So I've gone ahead again and built this one with Together AI, and you can see like, I can actually do it again to show you something. Um, okay. So you can see that whatever that we need, like everything in the runtime for CUDA, for PyTorch, everything that you need actually to run an inference and other peripheral packages here, they are all have been like installed in this package. Now, we want to use basically, as we are going to use Tavili as one of the search engines for our agentic APIs. So I got the key for that one too. And we are just going to set up the keys here. But the important part here is that we are going to define a Llama stack client. And the Llama stack client can basically take the distribution that we just built together. And we have a bunch of providers that, as we talked about, one of them is going to be the search APIs. So I'm adding it there. So let's actually build it together. So you can see that when we build this client, it's going to list everything that is available in this Together AI basically configuration here. So it lists out all the APIs for us, what we have for dataset. We haven't set for anything for dataset here, but for the models, we have defaulted to Llama 3.18b and everything around it. So these are other models that actually Together is providing. So you can see that for dataset IO, we have set we are defaulting to Hugging Face here. And we have the Llama guard as the safety, and for a scoring function we are defaulting to LLM as judge. But these are all the details. So my main point here is like you can actually see what is going on in your clients, so you will have access to all of this, and these are your settings. And from here, let's take a look at like what our clients, so models are listed here. So we can have access to many of these models. So our client was a Together AI client here, and you can see that these are the list of the models that they are actually providing through their APIs, which is everything from Llama 405V to 7TB, 8B, the vision models, etc., and the Llama Guard ones. So we are going to pick a model. We are going to default actually to 3.170b instruct, which is the medium-sized model that we have. Sorry, just a quick check to make sure there isn't a question. Cool. And then we want to run a simple chat completion here. So you can see that this should be familiar to many of us here. We have seen it in other places. So client inference chat completion. You're going to pass your model ID, you're going to pass your messages, you define the role. So for your role, system role, uh, you're basically defining your system prompt here, and this is your user query. Write a 2 sentences poem about llama. So let's see how it's going to do. Yep. So easily, this is like very trivial. So we got a 2 sentence poem about llama, but let's have a conversation with this one. So we are going to put actually two questions here, and then we are defining a utility function as a chat loop, and you can see we are going to keep the conversation history. So the first question is actually asking about the quotes from the famous PMs of England during World War II, and then who was the famous PM, and then asking for his famous quotes. So basically, we need to keep the chat history to understand the second question. So you can see here the model starts actually to output the famous quotes. I'm sorry, the prime minister, and it starts to uh, provide the famous quotes. Yep. So you can see here that it talks about Winston Churchill, and then we have like the famous quotes from him being listed here. Here is a more interactive, basically chat that we can build. I'm gonna skip this because this is gonna be identical to that one, but you can just interactively pass queries to this. One other point which is important for all of us, and this is like a great developer experience, is streaming. So we are providing a streaming output here as well, and the way it works, uh, you basically set up your chat completion, and you can set the flag for a stream to true. And as you can see, we have the event loggers in the client stack as well. So we are gonna run this and look at the logs basically for the responses. So you can see that this is basically providing the streaming. So and this definitely has been aligned with the service provider. So that service provider needs to kind of provide this service. So like Together AI is providing it here, VLLM, TGI, and everyone else is kind of providing it. So it kind of depends on the provider here. Then the other thing that matters for most of us when we are working with these models is structured decoding. So let's say that you want to get your response format in a JSON, and sometimes this is challenging for a lot of models, and we are going to use Pydantic here. And you can see that simply we define a class from the base model from Pydantic. And then we are going to do inference completion. So you set up your model ID again, you pass your user input, which is a question about Michael Jordan here. And you want to, so you can set your sampling strategy. We are setting it to greedy here with max token of 50. And then the response format here is like JSON schema, and how we are going to provide it. We are going to use the output class that we built here, output.model JSON schema. And if you run this, basically you are going to see that, okay, extract the information in a JSON format for me. So it could pick the name, the year of birth, and then the year that Michael Jordan was retired. So you get it in a nice JSON, which is very helpful for all of us, I guess, when we want to build API applications on top of this. The other important part that we discussed was the safety APIs. And Llama Stack basically provides guardrails and safety guardrails for you. So here we want to show you how it works. So I'm gonna put like we have put two unsafe. examples here. And from the client safety run shield, we are gonna actually run these queries through the shield or the through the guardrail and Llama guard basically here and see the responses. So first of all, it show you the available shield here, which is Llama guard 3 8B. Then we are checking the safe ones. So the first one is safe, the second one is safe, and the two last ones, which are the unsafe queries, you can see that we can catch them here. And we are kind of trying to gracefully handle this and saying basically, I can't answer this query. Can I help you with anything else? So this is the layer that we are recommending from the meta side that everyone needs to apply in their application, uh, because generally our thinking here is we want to make these models more friendly, but at the same time we need to think about safety. So we are providing this safety layer on top of our models to make sure that we build with safety in mind. At the same time, models are not regressing because of being too cautious. Okay, quick check if there are questions. No questions. Okay. So the next part is about Llama stack agents, and this is a hot topic. Everyone is talking about it. A lot of predictions says this year is going to be the agentic year, and super important for us. That's one of the main focuses for the Llama team and the Llama stack team. And if you look at really what do we need for building an agentic system, we need basically few things. One is memory for the rack system, and the other one, which is more important, is like tool calling. And of course, you need the inference system to be in place to kind of help with your tool calling and general LLM inference. So we have everything in place in Llama stack, and this is basically we have also from Llama 3 onward, the we have the built-in tools that some of them have been trained to work with the Brave search as the search API, and we have the built-in code interpreter. So here we want to take a look actually what are the built-in tools that we are providing. So if you look at the client and the tool group and we want to list what we have, so you can see that for the built-in tool in the Llama model, we have the code interpreter, we have the built-in tool calling for RAG here, RAG runtime, and we have the web search, which here we are going to use Tabuli search. So let's here define basically a search agent. What we are going to do here, again, you need your API keys for Tabuli and the other one, the Together AI, and we have done it already. So here we are going to have agent, and all of them, as you can see, coming from the Llama Stack client. So we are accessing agent, we are accessing event logger, and an agent config. So agent config is the key here. So basically, you are passing a bunch of parameters to configure your agent. What do we need? We need one model to run the inference. So we have picked the Llama 3.7TB here previously, and we are going to pass the same model ID to be the core brain for our agent. You have a system prompt, basically, that you can pass to this config. Similarly, you're going to pass your tools. So within the tool group, we are passing the web search here because this is what we are going to build a search engine. And yeah, so for shields and outputs, we are ignoring it right now for the purpose of just for the sake of demo here. So we are going to define this agent, and we are going to pass the user prompt. And so these are the two user prompts that we have here, pretty simple. And the way you want to start with is like you are creating a session. We are giving a name to this session, and it's going to be our session ID. And then for each prompts, we are gonna actually run it through the agents, which is gonna create a turn for us. And basically, we are passing the prompt as the user prompt. So let's take a look at this. So the first prompt, low, and the inference, or basically what is the response, is like, how can I assist you today? You can see the second one we are passing, which teams played in NBA Western Conference Final for of 2024. And for that, the model does not have the knowledge, so it has to go and search for this. So basically, it understands that I don't have the knowledge. I have to use one of the tools that has been provided to me. And which tool was here? It was a web search tool. So as you can see, the inference for the second one is basically a tool calling output. You can see that it's asking to call to a Brave search and with this query basically. So this is going to be the signature for your tool calling. And it goes ahead. I mean, normally you have to get the code or the function call from your model and go and run the code yourself. However, here, this is the beauty of Llama Stack. So it's going to handle it for you, and it's going to execute the tool basically for you. And as you can see, it has done the tool execution, and it brings back the top K results for you, which is a long list here. And then you pass the result of your tool execution back to your LLM to form a proper answer for you. And this is what you see. So the team that played in NBA Western Conference Final of 2024 were Dallas Mavericks and Minnesota Timberwolves. So you can see that this is a very cool property of Llama Stack that kind of don't need you to run your tool execution, and it kind of automatically handles it for you. So another thing that can make our life simpler when we are building these applications on top of Llama. So here we want to take a look at basically some of the telemetry and look at what were the traces that has been done. This is super important for production use cases that we are providing this telemetry. And it helps you to look at these traces because at the end of the day, you want to see what your model has done uh, and how successful it was. So you can do many things with this. Use your traces as kind of like training data if you want to use it later, or have some evaluation systems. I'm going to showcase some of this here. So if you look at this one here, oh, oops, what happened? Um, hmm, okay, live demos like always. So I just ran it right before this. I'm not sure what happened. But as you could see, it showed me the traces. I have another one just right after this. So let's actually take a look at that. Hopefully it works. So the RAG agent basically, this is the next demo. Here we are passing a bunch of documents and we want to build a RAG agent here. Uh, the way it works, we are basically using the document as one of the data types being provided in Llama Stack. And we are taking the basically ID here, and we are sourcing the data with the content. And you can see that we are going to use actually torch tune documentation. And as I mentioned, this is a fine tuning library in PyTorch. And over there, basically, look at the time. Over there, we are going to basically define how we are going to source the data here. We are going to define a vector database, and we are going to use our client.vector.dbs to register a vector database here. For the embedding models, we are using the famous all mean LLM L6 here, and we are setting the embedding dimensions. And then we are going to use the tool run and the rag tool to insert the documents into the vector DB. Then we are going to define our agent config, and from there we are going to pass the rag tool to the model and kind of define like the vector db here. So, and then everything is like what we have discussed before. So we are going to basically run this agent, create this agent, and then create a session. And then once we have created the session, we have the user prompt, and we are going to create turns for this. And this is how we are actually run the agent to access our documents in TorchTune. And what we want to understand is like, what are the top five topics that have been explained in these five basically documentations here. And if you go to TorchTune, you will find that this is basically what we are talking a lot about it over there. Fine tuning a custom chat model, fine tuning, basically using chat templates, and talking about tokenization, instruct model and its templates. So these are some of the topics that you can find in those basically documentations. Similarly, another showcase here about the code agent. This is basically using multiple tools here. So one of the tools is going to be code interpreter, and the other one is going to be a web search. So the idea here is like, let's say that we have a CSV model. You have some data here in your CSV model, and we want to derive some insights from the CSV model. What is it that it's doing? So what we can do here is like, we are going to configure another agent. I mean, all the standard stuff, sampling parameters, and then the model that we are going to use, a system prompt. And here for the tool, we are passing two tools, code interpreter and search, and then tool choice auto. Basically, we are letting the model and agent to choose. And so we are building the agent, session ID, create a session basically, and documents here are two user inputs. We want to understand that we want to first see what is in this CSV. So can you describe it to me? And then plot an average yearly inflation as a time series. Similar to what we discussed before, we are going to create turns, pass the messages as user message, and then we are going to print out what is happening here. Let's see. So as you can see, this was our user query, right? Can you describe this CSV? So it wrote a code for us to kind of load this CSV file, read this CSV file, and kind of go through the columns and print out what is it that is there. And if you can see here, it's using the tool execution and the built-in tool, the code interpreter, to run the code for you. So this is the code that it has produced, and it's going to run it for you and kind of drive the insights. So number of the rows, some stats about the CSV file that we had, the data types of the columns, and then you can see the final inference that here is like the CSV file contained 10 rows and 13 columns, describe the columns, and then the year of the column, data types, and everything around that, what we could actually see here as a code, that what we are thinking how to describe this. So we can see the result here. Then the next query was like, plot the average yearly inflation as a time series. And over here, you see that it again have another set of code, how to actually plot this. So we load the CS, plot it. So unfortunately, because this is like we couldn't show it as part of the shell script here, so I have to run it manually. Otherwise, you can see that the other code, which didn't need any plotting, and it was supported in our terminal, so in the shell. So we automatically execute it here. But for this one that needs a plot, I need to kind of do it manually. So basically, I copied the code and put it here, and just trying to plot the curve here. That what was the average yearly inflation. So let me do a time check. So this is like 40 minutes. I'm gonna take a pause here and see if there are any questions. Okay. I think we have like, we didn't have any questions. So I'm gonna go one more section down, then pause again. So Um, this is again discussing about the evaluation. How you remember how we talked about the telemetry and the traces that we can get from our model, and we can use them in different scenarios. So one of the things here, one of the scenarios is like online evaluation, basically data set collection. So let's say that we have used our model for tool calling, and we want to understand that how accurately our model has done this. Is it actually getting it right? Like, is it producing, is it outputting the right tool call each time when we are actually passing it? This is what we want to do here. So let's say that we have an agent, and for this agent, we are showcasing another model. Excuse me. We are going to use the 405B model, and then same story. We are going to set the web search here as the tool, and everything is standard, again, the system prompts and everything. And then we define the agent. So we pass the client, we pass the agent config, and we create our agent. And here, for the user prompts, we have three different prompts that all of them needs a web search. So basically, we need a tool calling here. We want to see like if the tool calling is actually happening here. So let's see. So the first one, we can see that it's calling to the Brave search. Second one, similarly, Brave search, and third one. So we had three tool calling. But how can we know about it? I hope that this one works, but let me show you before I run it. So we are going to access our client telemetry, and the query span is going to be, so we are going to pass the session ID basically that we just used here. So session ID that we created. And we are going to use the equivalent as the operation here. So the attributes are input and output, and so we are ignoring the shield basically here. But if you look at that, and if we run this, I'm gonna run it, but first, before, as the previous one broke, I want to show you like this is the input, right? So this is the input we ran, and like these are the outputs that we saw, the tool calling. And then you can see all these traces that we have. And how we want to use this one is kind of, let's post process this. So let's make it a little bit more organized, and put them in more of a kind of JSON format here in a dictionary that is easier to process. So this is just a utility function that we just organize our traces that we got from the agent logs, and this is agent logs that we just defined here. So that was a list that we added all the traces that we got from the telemetry to our agent logs. So this is the see here. So we want to go through that list and organize it a little bit better. That's what we are doing here. And we are putting the expected answer for each of those calls to be a Brave search. What we want to do, we want to run the score function and evaluate how our model has done here. So we are reaching out, we are accessing our scoring on the client and the score. And then we are, for the score function, we are going to pass as this one is a basic a subset. So if the answer is a subset of basically what we are looking here, so we should be good. This is when we are running this one and kind of, as you can see, this is the original list we created. These are the expected basically answers and the more organized version. And when we are running the scores, this is what we get. So we can see that for each of the calls, it actually worked pretty well. Um, and So this is one way to kind of assess our traces and make sure that we are on the right track. A time check, I'm gonna stop here really and see if there are any questions. I think we are kind of at a time, but just to encourage everyone again and reinforce the message to play with what I just showcased here and kind of have your own thoughts on that. Please take a look at the Llama Stack repo, go over this notebook, and let us know if you're running into any issues. Here is our Discord channel, so you can go here and actually start chatting with us. Again, this is a very new project, but this has been very welcomed from the industry. And our aim here is to make the developer journey easier and make the Llama adoption easier and make building basically applications on top of it as easy as possible and more intuitive. So please take a look at this, reach out to us if you are interested. And one of the places that you can also look, these are the current distributions. So these are the list of partners we have worked with: AWS Bedrock, Cerberus, Dell, Fireworks, and everyone here. So take a look at this. Let us know if you are interested to collaborate with us. Um, and yes, please let me know if there are any questions. I'm going to stop sharing the screen now.
Okay, that was great. We got it all set, and we didn't have any questions. I apologize. It's that one I sent you. So
Yeah, sorry, I kind of missed that. I just answered that, but yeah, that was miss.
oh, sorry, it's starting to play on my screen. It's done. But yeah,
No,
great job. Thank you, Hamid. Have a good night. Have a good rest of your
thanks.
day. I'm not sure what time zone you're in. All
Thank you so much. You too.
right.
Appreciate it. Thank you.
Bye.
Bye.